Hello friends, myself MB Gaddi, lecturer in E&C department from SAP and Trust Polytechnic, Sushi. Now, today I am going to discuss regarding Dcet PPTs and MCQ questions with answers for 6th semester electronics students, and my discussion topic is digital communication. For DCT, totally 180 marks will be there. It is a 3-hour session. Digital communications, whatever you have studied in 4th sem, just the details I am going to highlighting and discussing regarding the multiple choice questions with answers. First one, digital communication. Comparison of digital and analog communication system. Advantages of digital communication. Digital circuits operate by switching transistors on and off. Second one, by nature of digital signals make it much easier to obtain required performance from a large number of circuits. Third one, digital circuits are more reliable than analog. The effect of noise and interference are less in digital system. Fifth one, information can be easily gathered, stored, retrieved, and evaluated using digital technology. Sixth one, a mixture of traffic consisting of telephony, data, and video information can be easily carried. Seventh one, the capacity of certain existing transmission systems can be increased by employing digital multiplexing techniques. Eighth one, digital cable systems are more economical. Ninth one, digital communication is more suitable for newer type of transmission media such as optical fiber and waveguides. The frequency range is 30 GHz to 100 GHz. 10th one, digital signal characteristics are convenient for electronic switching. Disadvantages: the transmission of digital signals requires circuits with a very large bandwidth. Special circuits are needed to convert decimal counting system and analog waveforms into digital. Next one, baseband signal. The message or information which is to be delivered by a source of information is called baseband signal. Baseband transmission. A communication system in which signal transmission takes place without modulation are called baseband system. Baseband signals can be analog or digital type. In baseband transmission, the band of transmission frequencies supported by channel closely matches the band of frequencies occupied by the message. Next one, passband transmission. In this transmission, frequency band is much greater than the message frequency band. Second one, the process of modulation is involved for generating passband signal. Third one, FDM is used to create multiple channels for binary signals. Fourth one, transmission over long distance achieved. Fifth one, antenna with smaller dimensions can be used to radiate signals. Sixth one, effects of noise and interference can be minimized. The system is complex, costly. Modems are required for the purpose of frequency translation. Information theory. Transmission of information from one point to another is called communication. Information theory is a quantitative measure of the information contained in the message signal and allows to determine the capacity of a communication system to transfer this information from source to destination. Shannon gave the information theory information capacity or channel capacity. The maximum information transport rate bits per second that can be achieved with zero probability. Amount of information I into bracket mk is defined as imk equal to log of 1 divided by pk to the base 2 bits. Average information per symbol source entropy h equal to total information of the message divided by number of the symbols in the message. It is defined as h equal to I total divided by n sigma of I equal to 1 to m p of I log of 1 divided by pi to the base 2 bits per second. Bit rate. The basic unit of information is called the binary digit or bit, which is 0 or 1. Bit rate in digital telecommunication is number of bits transmitted per second. The units are BPS, bits per second, kilobits per second, megabits per second. Baud rate or signaling rate. It is the number of symbols transmitted per second. Bit rate equal to baud rate into number of bits of information to represent each symbol. Bandwidth or capacity. For digital signals, bandwidth is the data speed or rate measured in bits per second. Bandwidth equal to f2 minus f1. Highest frequency minus lowest frequency. Next one is sampling. Sampling is the process in which the amplitude of a continuous time signal is measured at discrete instants. There are three types of sampling. First one, natural sampling, instantaneous sampling, flat topped sampling. Sampling can be viewed theoretically as multiplying the original signal with a train of pulses with unit amplitude. Sampling theorem or Nyquist criteria. For proper recovery of original signal, the sampling rate must be high enough. The sampling rate Fs must be at least 2 times the highest frequency component Fx of the original signal. The relationship between the original analog signal and the sampling frequency is known as sampling theorem. The maximum sampling rate of 2 into fx samples per second or a signal bandwidth bx hertz is called Nyquist rate. Its reciprocal 1 divided by 2 fx measured in seconds called the Nyquist interval. Fs is greater than or equal to 2fx or Ts is less than or equal to 1 divided by 2fx. Fs is measured in hertz, Ts is measured in second. Aliasing effect. The high frequency signal, if sampled at too low rate, then the curve looks like a lower frequency. This is called aliasing. One of frequency looks like another. Fold over distortion. If sampling rate is Fs less than 2fx, then sidebands of the signal overlap cannot be recovered without distortion. It is called fold over distortion. Duplicate of the input spectrum folds back on the top of the desired spectrum. This type of sampling is often referred to as fold over distortion. Anti-aliasing, band limiting the signal prior to sampling with the help of anti-aliasing filter. Sampling at a frequency moderately higher than nominal Nyquist rate. Quantization. Quantization refers to the process of approximating the continuous set of values with a finite set of values. The input to a quantizer is the analog samples and the output is also one among a finite number of levels. If the quantizer samples are transmitted directly over a channel, we have a quantized PAM. If we code each quantizer sample into a block of its digit of transmission, we have PCM, pulse code modulation. In PCM system, the message signal is sampled and the amplitude of each sample is rounded off, quantized to the nearest discrete level. Therefore, both time and amplitude are represented in the discrete form. PCM is an extension of PAM wherein each analog sample value is quantized into discrete level. The combined operations of sampling and quantizing generate a quantized PAM waveform. Each sample is represented by a code number rather than the sample value itself. The code number is converted into its representation in binary arithmetic, that is base 2 arithmetic using an encoder. Hence, the system of transmission is called binary pulse code modulation. One more is DPCM. Differential pulse code modulation is a procedure of converting an analog into a digital signal. An analog signal is sampled and then the difference between the actual sample and its predicted value is quantized and then encoded, forming a digital value. Predicted value is based on previous samples. Delta modulation, DM. Delta modulation is a digitization technique that makes use of the sample to sample redundancies in an analog waveform. DM can be considered as DPMC using 1 bit per sample of the difference signal. The signal's bit specifies the polarity of the difference between samples and thereby indicates whether the signal has increased or decreased with respect to last sample. DM output is 0 if waveform falls in 1 represents rise in value. Delta modulation system require higher sampling rate than the PCM or DPCM. Delta modulation suffers from slope overload and granular noise. Next one, adaptive delta modulation. Granular noise and slope overload DM can be reduced by adjusting the step size in accordance with the signal being encountered. The step size should be kept small when signal changes are small. Step size should be increased in order to avoid slope overload when signal changes are large. ADM system adjusts its step size according to signal characteristics. Digital signaling formats, line codes. The encoding process maps digital code words into a sequence of voltage levels suitable for transmission over channel. It is required for the purpose of making the transmitted signal more immune to noise interference and other channel degradations. The representation of each code word is called character. Each event in a character is called symbol. Waveform formats. Depending on the duty cycle of the pulse, there are two possible waveform formats: NRZ, non-return to zero; RZ, return from the zero. Depending on polarity, based on polarity, there are three possible waveforms. Based on these two factors, different line codes are unipolar NRZ signaling, unipolar RZ signaling, polar NRZ signaling, polar RZ signaling, bipolar NRZ signaling, bipolar RZ signaling, split phase encoding Manchester code. Digital modulation techniques. Modulation is the process of altering some characteristic amplitude, phase, or frequency of a high frequency carrier waveform in accordance with the source of signals or baseband signals. Modulation is used in communication systems for matching signal characteristics, reducing noise interference, simultaneously transmitting several signals or a single channel, overcoming some equipment limitations. Low frequency analog signals are converted to digital format before transmission. Digital modulation techniques are used by sending binary information on analog carrier. Some of the digital modulation techniques are amplitude shift keying ASK, frequency shift keying FSK, phase shift keying PSK. Phase shift keying is further subdivided into differential phase shift keying, quadrature phase shift keying QPSK, minimum shift phase shift keying MSK, binary amplitude shift keying BASK. It involves switching keying the amplitude of a sinusoidal carrier to values off and on in accordance with the incoming binary data while keeping the frequency and phase constant. This is sometimes called off keying. BSK transmitter. BSK signal can be generated using binary waveform to turn the oscillator on and off. It can be generated by using electronic switch. BASK receiver. BASK receiver can be coherent BASK receiver, non-coherent BASK receiver. In ideal coherent detection, BASK signals an exact replica of the arriving signal is needed at the receiver. A phase coherent local carrier can be generated at the receiver by the use of very stable local oscillator. The cost of such a scheme may be excessive. Non-coherent BASK receiver. Non-coherent detection schemes do not require phase coherent local oscillator signal. These schemes involve some form of rectification, low pass filtering at the receiver. Binary frequency shift keying BFSK. It involves keying frequency of a sinusoidal carrier between values f1 and f2 in accordance with the incoming data while keeping the amplitude and phase constant. The information in FSK signal is essentially the frequency of the signal. In BASK, there are two types of detection: BFSK, coherent and non-coherent. Binary phase shift keying. Phase shift is the time difference between two sine waves of the same frequency. BPSK uses two phases which are separated by 180 degree. It is also termed as 2PSK. PPSK involves switching the phase of a sinusoidal carrier between two values phi1 and phi2 in accordance with the incoming binary data while keeping the amplitude and frequency constant. The information in a BPSK signal is essentially in the phase of the signal. BPSK is equivalent to multiplying the carrier signal by plus 1 when the information is 1 and minus 1 the information is 0. BPSK detection is a coherent detection. In a coherent system, the receiver compares the phase of the received signal with a reference signal. Differential phase shifting is a non-coherent scheme. In a DPSK scheme, the phase reference for demodulation is derived from the phase of the carrier during a previous signaling interval. Next one, multiplexing. Multiplexing is a technique that allows the simultaneous transmission of multiple signals across the single data link without interference. Types of multiplexing: frequency division multiplexing, time division multiplexing. In FDM, number of signals share a bandwidth of a common communication channel. Each signal to be transmitted over this channel modulates separate carrier. Each carrier is of different frequency. The modulated carriers are then added together to form a single complex signal which is transmitted over a single channel. TDM, time division multiplexing. TDM is a digital multiplexing technique for combining several low rate channels into a single high rate channel. In TDM, each signal can occupy the entire bandwidth of the channel. However, each channel is transmitted for only brief period of time. TDM is used mainly for digital communication. Continuous signals are not suited for TDM because of the signal is present at all times. Most TDMs are use PAM or PCM. Each cycle of TDM is called frame. Multiple access techniques. Multiple access is a multiplexing technique in which the signals to be multiplexed originate at different locations. There are three types of multiple access: frequency division multiple access FDMA, time division multiple access TDMA, code division multiple access CDMA. FDMA assigns individual channels frequency bands to individual users. Each user is allocated a unique frequency band. These bands are assigned on the demand to users who request service. FDMA channel is not in use. It sits idle and cannot be used by the other user. Example, radio and television broadcasts. TDMA, time division multiple access, shares a single carrier frequency with several users by dividing the transmission time into non-overlapping slots. Data transmission in TDMA system is not continuous but occurs in bursts. Transmission media. A transmission media provides physical path or the data is carried from transmitter to receiver. Transmission media can be classified as guided media. Guided media use physical cable or data transmission. There are three important types of guided media. Twisted pair cable. Twisted pair cable use the cable used for telephone systems. It is used to connect terminals and low speed data equipment to the mainframe. It is frequently pre-installed in buildings. Types: unshielded twisted pair UTP cables. A twisted pair consists of insulated copper wire arranged in a regular spiral pattern. It consists of two copper conductors, each covered with polyvinyl chloride insulation. The two wires are twisted about each other so that each is equally exposed to interfering signals picked up from the environment. Shielded twisted pair STP. Shielded twisted pair cable has a twisted pair covered by the metal shield and finally by the plastic cover. The metal shield prevents penetration of electromagnetic interference and crosstalk. It has performance equal to the coaxial cable. STP is more expensive than UTP. Coaxial cable consists of center copper conductor is surrounded by insulation such as Teflon. It is in turn surrounded by a tube shaped conductor, solid copper, solid aluminum or metal braid. An outer plastic jacket protects and insulates the braid. The outermost tube and the center conductor shares the same axis of curvature, hence the term coaxial. Coaxials support higher data rates, longer distances, and greater durability. They provide better protection from magnetic interference and electronic tapping. Optical fiber cable. An optical fiber cable is essentially waveguide or light. It consists of core surrounded by a protective cladding. Both are made up of either glass or plastic. The cladding has a lower index of refraction. This ensures that the proper interface is achieved so that the light waves remain within the core. In addition to protecting the fiber core from the nicks and scratches, the cladding adds strength. Most fiber cables have a circular cross section with a diameter of only a fraction of an inch. Some fiber optical cables only have a diameter of only fraction of inch. Some fiber optic cables only have a diameter of human hair. A light source is placed at the end of the fiber and light passes through it and exists at the other end. Refractive index is given by n equal to c by v. The optical window is that portion of the electromagnetic spectrum where the fiber is most transparent and efficient. For glass fibers 1300 nanometer is very popular. Mode refers to the various paths the light rays can follow. There are two types of multi-modes. Single mode. In multi-mode, LEDs are used as light source, and in single mode, lasers are used as light source. Based on the refractive index, variations and mode fiber optic cables are classified. Multi-mode step index OFC, single mode step index OFC, multi-mode graded index OFC. Now we are going to coming important discussion on Dcet MCQ questions, multiple choice questions. I have discussed several questions. Then the star mark indicates the correct answer. First question: digital communication is dash dash to environmental changes. Options are less sensitive, more sensitive, does not depend, none of the mentioned. Choice and correct answer is less sensitive. Advantages of digital communication are options are easy multiplexing, easy processing, reliable, all of the mentioned. Correct answer is D, all of the mentioned. Third question: what is necessary for digital communication? Options are precise timing, frame synchronization, character synchronization. D. All of the mentioned. Correct answer is D. All of the mentioned. Next question. Analog to digital conversion includes options are sampling and quantization, none of the mentioned. Correct answer is sampling and quantization. Next question. Which signals are a function of time? Options are random signal, deterministic signal, random and deterministic signal, none of the above. Correct answer is deterministic signal. Non-uniform quantization includes op- options are compression and expansion, none of the mentioned. Correct answer is C, compression and expansion. The quantization will be finer when options are smaller the number of discrete amplitudes, large the number of discrete amplitudes, does not depend upon amplitudes, none of the mentioned. Correct choice is large the number of discrete amplitudes. Next question. Different cases of sampling include first one ideal impulse sampling, flat topped sampling, sampling with rectangular pulses. D. All of the mentioned. Correct answer is D. All of the mentioned. The signals which are obtained by encoding each quantized signal into a digital word is called as options are PAM signal, PCM signal, FM signal, sampling and quantization. Correct answer is PCM signal. Next question. Quantization noise can be reduced by dash dash number of levels. Options are decreasing, increasing, doubling, squaring. Correct answer is increasing. In PCM, samples are dependent on dash dash. First one time, frequency, quantization level, interval between quantization level. Correct answer is time. Delta modulation uses dash dash bits per sample. Options are 1, 2, 4, 8. Correct answer is 1. Adaptive DPCM is used to options are increase bandwidth, decrease bandwidth, increase SNR, none of the mentioned. Correct answer is decrease bandwidth. Which waveforms are also called the line codes? Options are PCM, PAM, AM, FM. Correct answer is PCM. When pulse code modulation is applied to non-binary symbols, we obtain waveform is called as options are PCM, PAM, M array line codes. Correct answer is M array. Examples of PCM waveforms are options are non-return to zero, phase encoded, multi-level binary, all of the mentioned. Correct answer is all of the mentioned. Which type is used and preferred in digital logic circuits? NRZL, NRZM, NRZS, none of the mentioned. Correct answer is NRZL. Which method is called as differential encoding? NRZL, NRZM, NRZS, none of the mentioned. Correct answer is NRZM. The return to zero waveform consists of unipolar RZ, bipolar RZ, RZ AMI. All of the mentioned. Correct answer is all of the mentioned. In which waveform logic 1 is represented by half bit wide pulse and logic 0 is represented by the absence of pulse? Options are unipolar RZ, bipolar RZ, RZAMI, Manchester coding. Correct answer is unipolar RZ. In which waveform logic 1 is represented by equal amplitude altering pulses? Unipolar RZ, bipolar RZ, RZAMI, Manchester coding. Correct answer is RZAMI. TDM is used to, options are increase the information transmission rate, use only one carrier frequency to handle different signals. Third one, to use different frequency bands for different signals, to protect all signals in PCM from quantizing noise. Correct answer is use only one carrier frequency to handle different signals. Which has greater bandwidth? Options are TDM, FDM, TDM and FDM, none of the mentioned. Correct answer is FDM. Which has lower noise immunity? Options are TDM, FDM, yep, TDM and FDM, none of the mentioned. Correct answer is TDM. Next question, which has lesser average packet delay? FDMA, TDMA, dynamic FDMA, none of the mentioned. Correct answer is TDMA. CDMA is, options are similar to FDMA, similar to TDMA, combination of both, none of the above. Combination of the both. Next question, which needs precise time coordination? Options are CDMA, TDMA, CDMA and TDMA, none of the mentioned. Correct answer is TDMA. Telephone communication system uses dash dash type communication system. First one, FDMA, TDMA, CDMA, none of the above. D, none of the above. Principle used in propagation of light within the optical fiber is, options are refraction, total internal reflection, diffraction, none of these. Total correct answer is total internal reflection. Next question, unguided media use dash dash transmission media. Twisted pair cable, optic fiber cable, air, coaxial. Correct answer is air.